Hi, everyone. This is Amitabh Misra. I am VP of Engineering at Snapdeal.com, and we are going to talk in this webinar about, what a background about our company, the growth that we have seen, and how has our technology and the choices we have made in building our technology helped in propelling that growth. So, Snapdeal is India's largest online marketplace. We started about 4 years back, but as a deal site, and we were the largest player in the deal site when we realized that we could do a lot better by becoming a product-based marketplace. So we started that journey 2 years back, a little over 2 years back, late 2011, and started building our platform very rapidly. Today we have grown to 20 million plus subscribers. We shipped to 4,000 plus cities, and we are very rapidly expanding with a goal to reach every single zip code in the country as diverse as India. That's a very, very big challenge. We have 6,000 plus brands, 4 million plus products, and 500 plus categories altogether. There is a lot of robust activity that we've got on our site. We sell a lot of stuff from electronics to fashion to appliances. We've even sold cars on our site, and we have done a whole bunch of bombastic growth over this period of time. What has allowed us to do that well in business and grow that fast, like 10 times in 2 years, has primarily been on top of the technology that we built. Our entire technology infrastructure has been built inside. It's custom made. We've not housed much of software that is available, paid software. We built pretty much everything in-house, and that's a very mighty feat considering for a full-fledged e-commerce site there are a lot of complex pieces. So we have a multi-seller catalog system with ranking and real-time changes in ranking, millions of buyers coming in, thousands of sellers dealing at the same time, changing their prices, inventory, and then that leading to changes in the way products are bought. Then we built search from scratch. We built a content management system which takes feeds from various levels of seller stack. So we have technology to allow very rudimentary sellers to come on the site and push their product, as well as all the way sophisticated technology of integrating with seller platforms in a web services way. And this system is capable of creating more than 50,000 products in an hour and taking updates up to over 1 million an hour. Updates ranging from everything, content edits, price, inventory, everything. We also built, our personalization and recommendation engine in-house. We have a very sophisticated supply chain technology that sits on top of the ecosystem of all the courier companies, and in a real-time basis, packet by packet, it chooses the most optimal courier. Optimization being based on price, reach, time to delivery, and so on. We also have a very sophisticated back channel, targeted communication system that runs off a massive CRM database where we segment our customers, add personalization, and then send out very, very focused targeted communication. Based on the usage of that communication of our entire buyer base, we take the feedback into the CRM database and then send even better targeting next time. So then we have also a very, very powerful analytic system. Our analytic system feeds both the biotechnology as well as cellular technology. It also actually helps all the internal business decision making. Our entire company is run of numbers. Every day we look at numbers to make decisions. So what has allowed us to build all this system very, very fast, and mind you, we have only about 120 people team till about 4 months back, and now we have scaled to 200. But this vast majority of this technology has been built in 2.5 years by 120 engineers. What has allowed us to do all this? One of the primary thing is the architecture that we have got. We have a fully distributed service-oriented architecture made up of 30 standalone subsystems. When I say standalone systems, each subsystem is different all the way from its code base to its deployment to its development cycles, the release cycles, the team that develops it, and so on. And all these systems talk through RESTful APIs. So what that has done is that, when it comes to developing it fast, we just pick up a system, put trust on it in terms of team, effort, and everything, and go and roll it out. When there are problems, it's very easy to narrow it down to a certain system and isolate the problem. When it comes to scaling, if you understand, in a very large system, necessarily it doesn't happen that all parts of the platform need to scale at the same time. But since we have a very distributed system, depending on what element of our need is growing, we just focus on that subsystem and grow it liberally, while other systems just remain the same. So that's what the underlying hardware. We are on cloud, and cloud has allowed us to grow a great deal. While our business scaled, there have been moments when we have added 50 machines in a day. When suddenly the traffic went 2 times based on some promotions and stuff like that we did. And it would have been impossible to do these kind of things, were we not on cloud. And so each subsystem is on a multi-node cluster spread across 2 availability zones, data also being replicated across 2 zones. And each multi-node cluster would basically mean everything like the application server, the file system, the database, the NoSQL technology if you're using any one of them, everything, queues, everything all put in a multi-node cluster environment. So overall, with the distributed system service-oriented architecture with cloud, this forms a very high performance, high availability architecture and allows us to grow very, very rapidly as we build more and more features on top of it. So one of the biggest challenge in building this complex system very fast is building the team that would be able to deliver. We grew in 2+ years, a little over 2+ years. We grew from 200 to 220 to 200 plus, and with a very, very young experience-based engineers, median age of about 2.5, we have built all this. And hiring, as you know, across the world is very, very hard. So in India, it's also incredibly difficult because a lot of good engineers leave for US. And so, it was more hard. So what we did was a couple of cool things. First of all, we have a very specialized HR team which just specializes on tech recruiting, and they're themselves engineers and MBAs. That allowed us to ramp up our team very effectively. We also have managers who are very hardcore techies. So, a lot of them are MBAs themselves. And that helps attract a lot of people because the kind of environment they look forward to is one where they'll have a great amount of learning and they'll have great amount of contribution to make. We did a lot of events and activity across the country. We go to every single city to hire talent and bring them on board. References, of course, as everybody knows, play a very, very big role. On top of all this, we are able to convince people that, once they join a company like Snapdeal, as opposed to, a very big multinational, what they're building directly affects their life and the lives of people around them. They're closer to market, because they can't rely on other people. They have to solve all the problems themselves, so they have an accelerated learning curve. And then an opportunity to create enormous wealth in the country. All these things are basically things that people value. So once we were able to build the team, which happened, of course, progressively, the next thing was how does the team deliver at this fast pace? Because, not all teams, all engineering teams in the world or in India develop things in that fast manner. We have comparable e-commerce companies who've taken like 6 years to build the platform where they are today with like 3 times more people. Here we have like 100 plus people, young energetic team in just 2 years building this platform. So we did a lot of things in terms of how we run our, engineering organization. The first thing is that every team member is encouraged to, be like an entrepreneur. So the development model is very ownership driven. The teams don't own technology deliverables. They own business metrics. So, for example, a search team, would not own how much, data they can ingest and how much search queries they can support and so on. But they would own metrics like search NPS, that's Net Promoter Score, that how satisfied are people with search results. Or they would own metrics like how many orders out of all the orders that we get come from search. And, metrics like in how many clicks, in how many scrolls can people get to the search results that they're looking for, and things of that nature, things that directly impact the business. So what that helps in doing is aligning business priorities in a very, very effective manner. The second thing, of course, we have agile model that is followed. But, one of the key things that we have done to make it more effective is that the interaction between teams is very, very informal. All the decision making in terms of, technology roadmap planning, decision making, what needs to go in, what doesn't need to go in, how much they need support from other teams. All this interaction is very informal. A vast amount of our meetings happen on the corridor. We stand there, make a decision, just in 5 minutes flat, we make a call and we move on. And it's okay if people make mistakes, but, people are encouraged to have a balance, between the speed at which they execute and the accuracy at which they execute. So that takes me to the next point. We encourage people to take risks. So not to be too conservative and designing a perfect system, because in our business, this e-commerce industry itself in India is very, very new, and nobody knows how things will evolve or what new things buyers will lap up in 6 months from now. So it's very important to do extremely fast iterations while we're building subsystems and features, and that can only happen if there's a balance between thinking and planning and execution. So, we iterate at a very, very rapid pace. We have typically, more than 60, 70 releases in a month now. Some days, actually, we go all the way up to 10 releases in a day. And the reason why we are able to do that is the combination of our technology architecture, the way our teams operate, and the risk that we are able to take. Finally, we have each team having complete freedom on the technology choices that they make in terms of adopting a technology, doing POC, which is why when we are stuck with problems, very small team like, 2-3 people can rapidly explore a whole bunch of technologies that are out in the market and then deploy them to very effective results. So that kind of brings me to the end of this presentation that I made. I'll be happy to take any questions that are there.
Thank you, Amitabh. This is Srini. I am from Aerospike. Thank you, Amitabh, for doing such a great job of explaining how Snapdeal has scaled 500% in such a short amount of time. I would like to maybe ask a few questions and have a discussion with you on some of the issues that you just outlined. First, I'm curious about one thing. I know that you did an extensive evaluation of multiple NoSQL database products recently. So could you add more color on your evaluation as to the criteria you used and for what application you considered it for, and how you made the choice?
So, as our technology scale, the biggest challenge area that we faced was, as a seller base swelled and our catalog systems swelled, and we have a multi-seller catalog system, so we have huge activity of sellers competing with each other in terms of offering products. What that essentially means is they needing an ability to rapidly change price and inventory, and that really means bulk uploads of updates running into hundreds of thousands. So as both sides of the equation, buyer-seller swelled, our needs to in real time to be able to ingest huge amount of updates while not degrading the experience of the buyer on the front side, really were our biggest challenge. So, what we had in terms of technology till that point was, we have a MySQL as an authoritative data source, RDBMS, and we were using MongoDB as NoSQL, where, we were able to scale to some extent, but the moment the updates went beyond 250 per second, we were unable to scale Mongo to reads at more than 5,000 hits per second. And actually it started degrading even at 3,000, but still it was performance which was acceptable but clearly not scalable. Our requirements were that our read performances at those rates should be sub 15 milliseconds and in many cases sub 5 milliseconds. And Mongo was not scaling because, it would lock up stuff when updates were going through. And we clearly saw that in subsequent months, and we started the study back in August last year, 2013, that, we would need, 5,000 was what we required then, but we would need to rapidly climb to even bigger scales, like 10,000 reads per second while having 500 writes per second. Mongo obviously wouldn't have worked, so we started evaluating a whole bunch of technology solutions. A primary criteria being, number one, that the technology should be able to support these many of concurrent reads, actually at least 10 times more than what our requirements is now, because that's how fast our business has grown. And we didn't want to look at another technology for next 1 year. The second criteria was, while it is handling these many concurrent reads and writes and performing at, let's say, 5 milliseconds per response time, we wanted that to be, 95 percentile or maybe 99 percentile of the cases. So while many technologies, NoSQL technologies were able to give an average response time of sub 15 milliseconds, but, when it came to the last 10% or last 20%, it sometimes very rapidly degraded. So for us, that second criteria that almost all buyers should experience the same response time was very important. And finally, cost effectiveness. we are a startup company. We have not all that much cash to spare in terms of paid technology. So we were looking for something that is also cost effective both in terms of if we were to get support for that, as well as the cost of hardware that it runs on. And so we evaluated a bunch of NoSQL technologies, and finally we zeroed in on Aerospike that gave us the best consistent performance. So then we went ahead and picked up Aerospike.
Yeah.
Today, for example, Today our system actually handles, just to share you where we are now, even more than what we had planned. So it handles, we have seen volumes up to 70,000 reads per second, while we have taken 500 writes per second. And the performance is just fine.
Excellent. It definitely makes me happy. Since we built Aerospike to handle these kinds of use cases. Now, I'm going to ask you something about, what you mentioned about having 60 releases a month. I have been, in the internet business for a while, in mobile especially, at Yahoo and so on. And it was always a great challenge to not regress when we made these releases. So I'm interested in your thoughts on how, I like the fact that your team is agile. In fact, that's how we run our teams here, as well as many of our customers. But I know that you must have some really sophisticated ways of making sure that your products keep marching forward, in spite of the number of releases you make. Can you talk a little bit about that?
Right. So I think one of the primary things is, of course, the kind of testing we do. So we knew that we were going to. So a lot of companies, when they do agile, they also have this concept of test-driven development. So we didn't go for that. We went for a separate QA team, which can speed up the testing process. So we have very rapidly, building automation suite. We have all kinds of levels in that. Security testing, performance testing, functionality testing, and so on. So that's one element of it. The second element of it is that we have, as I said, we are willing to take risks. So if there are issues, we'll be willing to try them out. So if things fail in production, our philosophy is basically fail fast. So if things fail in production, we have technology to do one-click deployment, or one-click, we take it out in a matter of few minutes, and we very rapidly go and fix things. So the teams are ready. We generally do our releases in the nighttime, late night, and teams are ready. And if there are issues, we very quickly go back and fix those issues. And finally, the architecture itself, because it's so distributed, and I'll tell you, things are so distributed that we generally have some sort of thumb rule that if a system is getting over 50 tables, these many, classes and so on, then we should separate it out into a smaller piece. So what that does is that releases are going one after the other, but they're going in smaller pieces, small modules. And if there is an issue, it is caught very, very quickly, and it doesn't spill over to too many systems at once. So making these very, very small modular pieces, a lot of companies have tried distributed systems, but generally when you look at the system, each module itself becomes very big. And if a module is very big, the chances of regressions are far higher. However, modules are small and you have a team which responds very, very fast. Fail fast allows us for very high quality release. So, in our history of maybe 2 years, I could count maybe less than maybe 20 releases that we had to roll back. That's it. We never had to roll back releases. Either we didn't have problems, or we had problems that small enough that we could live with it for 1 or 2 hours, and then we could put a fix back.
Oh, that's fantastic to hear. It looks like you really figured this out, and it works well for you. Another question I had was about your use of Amazon Cloud. Could you talk a little bit about what works well and what doesn't? The reason I ask is, we have, Aerospike has a lot of customers who we worked with, and many of them start off in the cloud, and then over time, when they become really large, they do move to their own data centers to deal with predictable costs. And they're also interested in predictable latency, like what you spoke about, 99% under 5 milliseconds. So I'm kind of curious about your thoughts on how you think Amazon can be leveraged. It looks like you've leveraged it really well. So.
Right. I think we would be probably one of the biggest, certainly the biggest player in India, maybe one of the bigger players in the whole world, the kind of infrastructure we have, supporting 20 million users and 20,000 plus sellers, and that much activity going on. So, Amazon has really worked for us very well. So in terms of performance, we see calls across network over RESTful APIs not adding more than maybe a couple of milliseconds. That's the network latency, and we see it very, very consistently. So we don't generally see problems with that. The second thing is the stability of the hypervisor and the virtual machines that we spin. In last 2.5 years that we have been using Amazon in a big way, we've hardly seen maybe 2 or 3 servers that just crash. So they've been very stable. Amazon now provides disks with IOPS in the order of 4,000. So if you really need a lot of high speed on IOPS, especially in some of the high performance RDBMS solutions, you can go for that. So in terms of performance and reliability and everything, I think Amazon has worked really well for us. The other thing, as I said, one of the primary benefits that we got from Amazon was, that our business is expanding so fast that, there is no way we could have done it anywhere else. Adding hardware and storage and memory and everything that goes into building that, I don't think we could have done it anywhere else. Now, there are some challenges as well, in a place like Amazon. One is that, Amazon platform is like almost do-it-yourself. So if there's an engineering team which doesn't have the capability to understand all the layers of the stack, from operating system issues to network issues to internals of JVM to low-level database issues, you'll have trouble. Generally, when you go on hosting environments, you get a lot more support, but Amazon is more like do-it-yourself. So if you can't figure out the problems, you may have challenges. And we didn't have those challenges because, our tech team here understands those things, most of those things very deeply. Another thing that there's a challenge in Amazon is, it's a little harder to figure out, costs in terms of if you have a whole big infrastructure, then breaking it down into smaller pieces as to, what this subsystem costs as opposed to that subsystem. And when I say subsystem, I mean a bunch of servers with some storage and bandwidth usage. So it's a little harder to break it down in terms of planning and such. But having said that, Amazon costs are generally very, very low, and they keep dropping their cost by themselves. So we don't have to go and negotiate with them to get special rates. They'll come and, every quarter they'll announce that our storage cost has gone down by this much, or our bandwidth costs have gone down by that much, or, compute have gone by that much. And they just pass on the discount to us. So I think for a company that is in a hyper growth phase, it may not be wise to not be on cloud, but once a company has stabilized, then maybe a company can consider comparing these things and optimizing for, once your goal is not revenue, but, the cost side of things, then you might want to, consider other options.
That's a great answer to my question. I have just 2 more questions. The first one is, your perspective on growing such a company in India, So I see, Snapdeal, Flipkart. I mean, there are a few companies which are now in hyper growth. So can you kind of talk a little bit about your learning and and the environment and how you're part of it and what you see happening?
So when you ask about the environment, is it about you mean the business side of thing or the technology side of thing?
It's more your perspective, your personal perspective on what's going on, so to speak. Technology, business, you can pick whichever I think you think is the most important trend that you see is happening and will continue to happen.
Okay. So I think what is certainly happening is that India, for example, is one of the last frontiers in terms of e-commerce. So we've seen very large e-commerce companies like Snapdeal and Flipkart coming on board. But the interesting thing is that the size of the business that is getting built is, if you compare with markets like US and all, it's happening at a much more rapid pace. It would have taken an Amazon many years, many years to come up to $1 billion in size, but and many years to build the technology platform to be able to support that kind of volume. But in India, with just 100 people, we were able to build it in 2 years flat. And with the kind of experience that I talked about. The second thing is that Indian market is expanding very fast. My sense is that e-commerce will have a far higher penetration in India than it has in developed world. So I think it'll be crossing even the most penetrated markets like South Korea, who have 12% retail on e-commerce. The reason is very simple that the organized retail, the physical retail, is not that developed and it's very costly. So physical retail cost per square foot area, maybe costing like 0.5% for Walmart in US, but in India it would be like 8% of the cost of this thing. So physical retail has a very tough challenge of real estate that is going to face a huge amount of competition from online, which basically optimizes on these costs. And finally, India is a very diverse country, so you have very big cities and you have like really way off townships. So the reach of an e-commerce company in the assortment that it gives is very huge. So we see a lot of business coming from tier 2, tier 3, tier 4 cities. So my sense is that, not only that we are going to grow very fast, very big, but it's very likely that in maybe 5 years from now, these companies will probably be the biggest one of the biggest e-commerce companies of the world, maybe outstripping companies in the developed world like United States and South Korea and stuff like that.
That's great to hear. One of the things you just said, which resonated with me particularly, because when we founded Aerospike, our goal was to essentially build the technologies which were inside the large companies like Google, Facebook, and so on, and make it available to everybody outside, so the new Googles and Facebooks and Amazons can be built faster. So it looks like you are doing that in your company in India, and we've seen other customers, even in the US, grow to Google scale in 3 years. Using some of the technologies we built as well as what others are building. So this is actually an exciting time, I think, for people like us.
Absolutely.
The final question I have is a very simple one. What is the single most important thing you think in your job, on a daily basis, that you kind of worry about and want to get right?
I think it'll have to be hiring. Because, while we have been able to hire a lot of smart people, that remains a very big challenge. The speed at which technology changes, the level of sophistication that we require, it matches best of breed in the world. But the availability of engineers in India is very scarce. So I would say what bothers me most on an everyday basis, on an hourly basis, if you will, is hiring the top-notch talent.
And this is the same answer I hear to this from many people. So I think this is a great point. So thank you for your time today. I definitely enjoyed it, Amitabh, your answers as well as your explanations. I learned quite a bit. I hope it'll be equally useful to the other listeners. Thank you.
Thank you. Thank you so much. I enjoyed talking. Thank you.
Okay.